Hello everyone. We are the students of Ashokrao Mane Institute of Pharmaceutical Sciences and Research Survey, and we have an opportunity to conduct the seminar of subject quality assurance. And our question is, define airlocks and list different types of airlocks and explain their working. The seminar is presented by Ms. Nehal S. Patil and Ms. Amarja S. Mane, and the seminar is guided by Mr. A. N. Dhagesar. First question: what is an airlock? An airlock is a traditional space located between two areas of differing cleanliness or contaminant levels. It equipped with doors that cannot be opened simultaneously, maintaining controlled conditions in one area while personal materials are moved into another. The core function of airlock is controlled airlock and pressure differentials to prevent the contamination. In pharmaceutical facilities, airlocks are used to protect the sterile or controlled environments and ensure the compliance with GMP regulations, which are essential for product quality and patient safety. There are three types of an airlocks, that is cascade airlock, bubble airlock and sink airlock. First type, that is cascade airlock. A cascade airlock operates on the principle of pressure differentials, where each conduct room has an progressively lower air pressure as one moves from a cleaner to less cleaner area. The airlock is positioned between the rooms of different cleanliness classifications, ensure air always flows from the cleaner area, that is high pressure, to the less clean, that is low pressure. This continuous airflow direction prevents contaminants from the migrating into cleaner areas. Cascade airlocks are widely used in pharmaceutical environment because of their simplicity and effectiveness in the materials, cleanliness and contaminant, especially non-hazardous or non-sterile environments. There are map of the cascade airlocks. Let's see how it works. In a cascade airlock, pressure differentials are key to the maintaining proper airlock directions. Air naturally flows from high pressure areas to low pressure ones. So the airlock is designed to maintain a higher pressure in the cleaner room, a medium pressure inside the airlock, and a lower pressure inside adjacent less clean room. This gradient prevents contaminants in less clean area from flowing back into the cleaner areas. It is an ideal solution for general contamination control in environments where sterility is not critical. Typically, doors on both sides are airlocked and interlocked to prevent the from being opened simultaneously, maintaining the pressure differential and ensuring the contaminant of contaminants. Second part, second type is bubble airlock. A bubble airlock is designed to create a zone of positive pressure, ensuring that the air pressure inside the airlock is higher than in both adjacent rooms. This higher internal progress pressure forms a bubble that acts as a barrier to contaminants, preventing their ingress from less clean environments and their egress into more controlled areas. The positive pressure of forces air to flow outward from the airlock when any door is opened, effectively preventing contaminants from entering the clean area. Bubble airlocks are particularly suitable for environments where contamination control and contaminant are critical, such as sterile manufacturing, clean rooms, and biotechnology labs. There are again map of the bubble airlocks that give direction of bubble airlock room space. Let's see how it works. In a bubble airlock, the air pressure within the airlock is set higher than in both adjoining areas. When a door is opened to either a cleaner or less clean space, the higher pressure inside the airlock ensures that air flows outward, preventing the movement of particles, contaminants, or airborne microorganisms into more controlled environment. The airlock doors are interlocked to ensure that only one door can be opened at a time, maintaining the air pressure in preventing any sudden loss of contaminant. This method or pressure control is highly effective in ensuring that contaminants from less clean areas do, do not enter clean rooms, and that particles generated within the room do not escape to surrounding environments. Third type is sink airlocks. A sink airlock is a type of airlock that operates with a lower internal pressure than adjacent rooms, creating a sink effect that draws air into the airlock. This design ensures that the contaminants within the airlock are contaminated and prevented from escaping into cleaner areas. The sink airlock is particularly useful in environments where hazardous materials, potent compounds, or biohazardous agents are handled, as it helps ensure that any airborne contaminants or hazardous particles remain confined within the airlock or the less clean zone, thereby protecting both personal and clean environment. There is a map of sink airlock. How it works. The principle behind the sink airlock is straightforward. By maintaining lower pressure inside the airlock than in adjacent spaces, air flows from the higher pressure zones, preventing contaminants from escaping into the cleaner or less contaminated areas. The method is particularly effective in environments that require contaminant of hazardous substances, as airflow helps tap potentially harmful particles within the airlock rather than allowing them to spread to areas require high cleanliness levels. For intense in facility handling potent activity pharmaceutical ingredients or dangerous chemicals, the sink airlock helps isolate the contaminants, preventing them from migrating into other parts of the facility. The airlock's lower pressure draws in air from the surrounding rooms, ensuring that any contaminants are trapped within the airlock or directed into specialized filtration systems such as HEPA, HEPA filters, that is efficacy particulate air, that clean the air before it is recirculated or expelled. Thank you.